Now semi-metals, so the semi-metal here is not actually the shell or the rock, it's the sand. But semi-metals have properties of metals and non-metals. That's why we call them semi-metals. They sit in between. Their conductivities can vary considerably with temperature. So if I take silicon, it's a bad conductor of electricity, pure silicon. If I heat the silicon, it becomes a better conductor. I continue to heat it, it gets better and better and better as I heat it. With semi-metals, the conductivity of the substance goes up as the temperature goes up. However, with metals, if you heat the metal and try to put electricity through it, it's harder to get the electricity through than if you let the metal become cold. So it goes the opposite way for metals and semi-metals. Now the conductivity, while it varies with temperature, it can also be changed if you mix semi-metals with other elements. So if you actually purposely contaminate your pure semi-metal with, say, boron or arsenic, we can actually improve the conductivity of the substance. Okay, and we call that doping. That's how the whole semiconductor industry, computer chip makers, memory chip makers like RAM makers, SSD makers. So all of these computer chips are made by putting impurities into silicon and then using that to create logic gates and things like that for our computers. So that's how we make computer chips, by doping this silicon, which is a semi-metal, with these different chemicals. And generally they have high boiling and melting points, and they're usually brittle. So semi-metals have very, very high melting and boiling points, and usually they're brittle, but not always. So here's just a mathy question on density. So a rectangular prism of carbon has sides 20 centimeters by 12 centimeters by 5 centimeters. And we know that carbon has a density of 2.3 grams per centimeter cubed. What would be the mass of the cube? Okay. So mass is simply the density of the substance times the volume that it takes up. Okay, so it's the density times how much space it takes up. So let's figure out the volume first. 20 times 12 times 5, just 3 multiplications, gives you 1200 centimeters cubed. Okay, units are important here. So the mass would simply just be this times this, which is what we've got here, just the other way around, giving us 2,760 grams. So what does that tell us? So this is 1200 centimeters cubed, so it's about just big 1.2 liters in terms of water. It's about 1.2 liters, which is not very big, yet it weighs almost 2 kilos, or more than almost 3 kilos. You can see that having a very dense substance means that in a very small volume, we can have a lot of mass, okay? So that's what density is all about.